Okay, welcome to our third video of Lesson 1, Module 5. Hopefully you have these shapes all cut out and laying in front of you and ready for sorting. If not, you should probably pause the video so that you can get ready for that because we're going to jump right into sorting. Okay, so sort your figures into two-dimensional figures and three-dimensional figures. How do you know whether a figure is two-dimension, 2D, or 3D? Yes, two-dimensional is flat, and three-dimension shows the part that's behind there. It's not flat, right? Okay, so sort that out. Okay, so two-dimensional figures lie in a plane, another new word, and this is plane, and it is spelled the same way as airplane. Plane, okay? And it is a flat two-dimensional surface that extends forever. The surface of a piece of paper lies in a plane because it is flat. A pencil doesn't lie in a plane because it is not flat. But just think of like the top of your desk or the wall, right? These are different planes. They're geometrical thinking. So, you know, kind of what we're thinking about. All right. So our two-dimensional figures lie flat on a plane. Our three-dimensional figures do not because they are three dimensions. Got that? All right. Nice. Now go ahead and sort your two-dimensional figures into polygons and non-polygons. Okay. So you're going to sort them into polygons and non-polygons. Now, what is a polygon? Hopefully you learned about polygons before, but the word polygon literally means many sides. Poly means many, gon means side. And these many-sided figures are always closed. So they have to be a closed figure to be a polygon. They can't be there like G. You see how? It's just basically three lines, right? It's not a shape. It's not a polygon. Okay, now you have polygons and non-polygons. So we're going to take your polygons and you're going to sort them into triangles. So put all the triangles together and then all the quadrilaterals together. Quadrilaterals. Quad, right? Think people used to call their four-wheelers quads. I'm not sure if they still do, but you're going to take all of your four-sided quadrilaterals. That means four sides, right? Four-wheelers. And you're going to put those in one place. Pentagons, five sides, and hexagons, six sides. So while you're sorting, go ahead and sort those. And while you're sorting, think about what's happening to the number of figures as you're sorting. Okay? And if you need more time, you can pause the videos, get everything sorted, and notice that the number of figures is getting smaller and smaller, right? Because we started with 15 figures, and we are putting them into less and less groups, right? So we have less and less left. All right, so now we have 11 polygons that are sorted into, oh, there's only one triangle. You have one triangle. And 7 quadrilaterals. And 2 pentagons and 1 hexagon. Okay, check that. And then let's look at one more. Let's look at N right here. Okay. We sorted our figures into different piles, but some of the things could be into more than one group, right? So N is a polygon and a quadrilateral, right? Are there other ones that fit into more than one group? Probably, right? Okay, now we're going to use our figure sort to make a hierarchy of figures. Okay, so here's a hierarchy of figures. we have figures. All of these are figures. We have two-dimensional and three-dimensional. Then inside of two-dimensional, we have polygons and non-polygons, right? Non-polygon is kind of just like a line. Yeah. And then inside of polygons, we have triangles, quadrilaterals, pentagons, and hexagons. And this is a hierarchy, just like our hierarchy of musical instruments, right? Okay. This hierarchy starts at the top with the general category, and each level underneath shows more specific category. According to the hierarchy, what are some examples of special types of polygons? Yeah, here's our special types of polygons. They're more specific, right? Each category in the hierarchy shares the names and properties of the types above it. So a hexagon is also a polygon, is also a two-dimensional figure, is also a figure. You see that? So everything above it also applies to it, right? So a quadrilateral is a polygon and a two-dimensional figure. All right, so here, let's ask some questions. All pentagons are two-dimensional figures. Is that true or false? All pentagons are two-dimensional figures. Oh, true, right? We can see it right there. Yep. All quadrilaterals are polygons. True. Yes, good job. All quadrilaterals are polygons. All polygons are quadrilaterals. False. Right? There's different kinds of polygons. Not all polygons are quadrilaterals, right? Okay, good job. Next, we're going to explore the properties of quadrilaterals. Okay, so I do need to open here so we can check this out. We're going to look at some figures. Hopefully it will open quickly. We are working on classifying two-dimensional shapes according to their properties, right? There we go. Oh, I think that's the one we wanted. Yes. Okay. Figure ABCD is a quadrilateral. How do we know it's a quadrilateral? Can you put that in Edpuzzle? Number 1 in Edpuzzle. How do we know this is a quadrilateral? Yeah, it has 4 sides, right? Okay, is having 4 sides a property of quadrilaterals? How do you know? It's true of all quadrilaterals, right? All quadrilaterals have 4 sides. Let's look at some more properties of quadrilaterals. Okay. All right, check this out. So here's a quadrilateral. All right. What do you notice about the angles of this quadrilateral? Let's even change it a little bit. Okay. There we go. What do you notice about the angles of this quadrilateral? Okay, watch this. I'm going to pick up every angle and I'm going to put it here together, and they all add up to 360. The interior angles of a quadrilateral add to 160. Let's see, fly back. Yeah, let's try and make it a square. All right, well, that's a rectangle. Do you think the interior angles of a rectangle all add up to 360? Yes, they do. 90 times 4 is 360. All right. Okay, let's make it fly back. Okay, how about, can we make it a square? Ooh. Working on a parallelogram here. Opposite parallel sides. Yeah. Okay. Still adding up to 360, right? Not quite a parallelogram. Let's try for a square. All right. I guess it's a parallelogram. This is not a square because it would be 90 and 90, right? Close enough. Okay, but you see that the inside angles of a quadrilateral will add to 360. So there's a new property that maybe you didn't know about before. This measures of the four angles inside, right? The interior angles. All right. So if the interior angles of a figure measured to say 600, then it's not a quadrilateral. Okay. That's pretty cool. All right. And we have a video. And then you can go ahead and do your work. Save your pieces. Okay. I'll pass out plastic bags, but put your pieces in there because you're going to need them for your next lesson. Okay, we're going to stop there. I'll see you on the next video.